Oh, well. Okay. You guys really should come in person. It's much better in person. Okay, it's like the difference between a pre-recorded band concert versus going live in person. It's just a better experience. All right. Well, we'll make the best of what we got. So, good morning, welcome back, Happy New Year. Hope your break was fantastic. Mine was pretty good, I guess. Maybe not was it fantastic? It was fantastically relaxing. I did a whole lot of nothing, and it was great. But I also did a whole lot of reconfiguring and planning and thinking for the second semester. So, ahead of us for today, we are going to talk about the nature of math itself, give it a better definition. I've been ruminating on this myself for years, and I think I finally have a satisfactory answer, and I'm going to share that with you so that you can take that going forward, keep that in your back pocket. There's a set of questions to go along with it that relate to both my presentation today and the reading you did over break. So be prepared to answer those questions. Go ahead and open it up, and if you want to just like type in as we go along, perfectly acceptable. But before we get there, I do want to call your attention to that email I sent out yesterday. Just to make sure you've absolutely seen it, read it, heard it, I'm going to go through it with you all now that at least some of the class is here. Get to that in a minute, right? So, reminders and a couple changes for this semester compared to last. Remember, you are required to attend class twice a week, once on your color day and then once on Friday online. Now, your color day, you could be here in person. I highly encourage you. It's a much better experience, or online in Zoom as you are now. And that's the minimum at least required for attendance. Okay? The other days, your attendance doesn't count. But for this class, you are expected to at least experience that class on your non-color days. Whether that means you watch it live on YouTube, which I should check, make sure that's streaming. Yes, good, awesome. Hello, YouTube. Or if not live stream, you could at least watch the video version at a later time. Say because it's generally you're off class day, maybe you have a doctor's appointment scheduled or something and to get back to it later, that's fine. I don't care, just as long as you finish that class's material that day, I'm happy, okay? Now, so each week then, you will have that one class day to attend live on Zoom, the two others to view on YouTube. You'll have their classwork and homework associated. The Friday, when it comes up, to attend. There will be still the weekly writing assignment sent out each Monday, due the following Monday. So you've got a week to think about that. And for the most part, you'll be reading and taking notes over the weekend in preparation for the next week. This week I kind of want to get a head start, so I'm going to have you actually jump on the first section Wednesday night, and then we'll start the topic on Friday. It's a short topic, kind of review stuff, so it shouldn't be too bad. But in general, over the weekend. And that way, your first encounter with the topic will be from the text, which gives you an opportunity to, if you get confused at any point, you can write down questions and then ask me in class later. As opposed to if we went the other way, if I told it to you first, and then after class you realize you're still confused, and then you try to turn to the textbook, it's going to be much harder to get a direct answer. So that's why I have it in that order. Similarly, the quizzes happening every week are going to be more frequent. I'm really going to push for those once a week, except for this week. But I'm moving them to Monday, so they'll be at the beginning of the week. And so they'll serve two purposes. One, they kind of act as a reading quiz, okay? both for me to check and make sure, hey, holding you to doing the reading, but two, so that you get a feel at the beginning, okay, how well do you actually know this just off the bat? Just reading and be like, oh, I got this. Okay, how well do you got this already? Or do you need more practice? And so they'll let you kind of gauge where you are with the material at the beginning of the week, and then you have the rest of the week to work on that, to get the practice in. And you'll have the full week now to retake the quizzes instead of just the couple days at the end of the week. Okay? So I hope that works out in your favor. All right, SAT practice also has been moved to the weekends just to kind of offload some of the things on Friday. Apparently, like everybody's assigning everything to be due on Friday, so I'm going to move that item, hopefully free that up a little bit. Now, speaking of freeing up your time, the online stuff, the Khan Academy, gone, ditched it, I'm done. It was great for the summer, that worked really well. It did not work really well during the school year when we were trying to also work in tandem with all these other sources and top, and yeah, forget it. It caused more headaches than it was worth, so we're not going to use it. Of course, you're welcome to. It's a free resource. It's available. You can log on and do whatever you want with it if you find it was still helpful. I didn't delete it from the internet. It's just no longer required for this course. You're welcome. Okay? So instead, we will have just each section's practice exercises or worksheets that we've been having. Okay? Now, the length of those is going to be adjusted a little bit, and I'll talk more about that tomorrow because that comes in the study levels. And so the total amount of work actually is going to come down to you, so you'll get a chance to customize things a little bit. Okay? More on that tomorrow. Speaking of tomorrow, if you want to know what's coming up, the master schedule still exists. It's still a super awesome tool. You need to use it. I want to see all of the little dots in the corner that says so-and-so is looking at this. Okay? Use it. Check it often. Okay? As I plan things out, that is what I use. I don't, sometimes I write things down, but then I immediately put them online onto that spreadsheet so I can work out, okay, when can we fit this in? Oh, when's the test going to be? Oh, do we need 2 days on this topic, 1 day on that one? Right? It all goes right there. What's the assignment going to be? What's the activity for the day? Straight to the master schedule. So you can know as soon as I actually know, all right? It's there, use it. And back to Friday. So just fair warning, Fridays are still this grab bag because we don't always have a Friday class with the work schedule and holidays and such. So they're never reliably going to be the same thing. Some days, like this week, we will make use of it for a section. It'll just be a standard lesson. Here's the thing, I'll talk about it, you do some practice, back and forth that way. Other days, it might be an extra assessment day. We might have to use that to fit the test in. Some days we will just play math games because I still think those are very valuable and help expand your mind in new and different ways. So again, it's all on the schedule if you want to know what Fridays are going to be. They're all still required attendance, though. You can't just skip one because you don't like it. Okay, any questions about any of that stuff? No? All right, then let's dive into one of the things that has been bothering me for the longest of times, that I've been thinking about quite a bit, and that is, what is math actually? Because remember, I started undergrad college studying physics. Physics was pretty straightforward, okay? It's matter and energy and motion. For the most part. You could say physics is the study of motion, of matter and energy. And I was like, okay, but what is math? What is all of math? Let's put it all together, algebra and geometry and calculus. How can you really succinctly define all of that into one go? Oops, gotta get back to here. There you go. Right. And what does it mean to think about math? To solve problems in math. This is kind of a buzzword in the schools these days, right? We want to teach problem-solving skills, right? It's not just enough to know the math by rote, right? The worksheet of 100 exercises to just jot down and do in 15 seconds, right? That's not good enough. You need to problem solve with it. That generally means word problems, right? What does that look like? How do you actually do that? And even worse, how do you learn how to do that? How do you teach it? It starts with understanding what it is. So I'm going to share with you the results of my thinking this through. I've done a lot of research on this, looked things up and found things and summarized a lot of thoughts here. And so I hope that this is going to be useful for you going forward, to serve as this thought foundation, okay? A map, if you will, a blank map onto which you can start adding in where everything fits in. Here's the algebra component. Here's the geometry component. Okay, here's how they relate to each other. Here's how I can build upon those ideas together to overcome this obstacle. All right? The typical track, remember, is pointed towards calculus. Okay? And I think that was made pretty clear in the reading over the break, which I'm also going to draw in that mathematicians lament, a new perspective on what math is, or at least what it can be, that you don't always see in school. So here's where I started. What is thinking? What is true thinking? To have an original thought is to put ideas together in different combinations and see what happens. Right? It's almost like a miniature science experiment going on in your head. Right? That's real thinking. When you are thinking about something, you are listing, okay, what is this? What are the consequences of this? What if we combine it with that? Then what will occur? Right? It is not straight up recall of information. Okay, that's not thinking. Recall is not thinking. Your brain functions very much like a library. It holds and retains a lot of information. You can search and rummage through there and be like, somewhere around here I've got 2 + 2 = 4. There's that bit of knowledge. Okay, it's stored there. But that's not thinking. Recalling that, okay, looking it up in the library, doesn't require effort. It doesn't create anything new. Okay, that's just a fact that exists even outside your brain. You could write that down. Everybody knows that. That's not, in my opinion, thinking. Thinking requires some effort. It's putting things together. So when you take that 2 + 2 = 4, and now, what about this other one? 4 + 4 = 8. Take those together. How do they relate to one another? How do they combine? How do they compare, contrast? Right? That's the thought process. You understand the difference? And feel free to chime in here. I would rather this be more of a discussion than just a lecture here of my thoughts. All right? I'm going to take your silence to mean yes. So stop me at any point if I confused you. So that was thinking. And then what about this problem-solving thing? What are problems? You got to understand what a problem is before you can solve it. Okay? Problems, in my opinion, are different from exercises. I've often, in regards to your homework, I will differentiate a problem from an exercise. Exercise you already know how to do. Okay? A problem is a question you don't already know how to get to the answer. You still got to work through that. Okay? The exercise, well, I know how to get there. It's just a step-by-step process. Maybe it seems a little more boring. It's a little more tedious, right? Tedious things are never challenging. They're just long. You just got to get through the steps. I know how to do this. Oh, come on already. A problem you don't know how to do. Like, oh, wait, what do I do first? Oh, what do I do next? But am I actually going to get an answer at all? Right? That's a problem. But they can be thought of as just a new combination of inconveniences. Most problems can be broken down into a series of steps, right? So here's an example of an inconvenience. The light bulb burns out at home in your desk lamp. Light bulb burns out. That's an inconvenience. You know how to solve that issue. It's not a problem for you per se. Okay, I know how to change a light bulb. I go get the new light bulb, I bring it over, unscrew one, screw that one back in. Right there. Issue resolved. Light bulb changed. Now, what about you're here at school? What if one of these light bulbs burns out? Then what do you do? Let's pretend it's on you. You're the only one here, or you could put it on me. What do I do? What would I have to do if one of these light bulbs turns out? I have no idea what kind of light bulbs this takes. It's in a little box. Is it a fluorescent? Is one of those long tubes? I'm guessing it's a fluorescent tube, right? So it's like this long. Okay, it's also way out of my reach. Okay, I can reach all the light bulbs in my house. I have a little step stool for the ceiling light. I would need to get a ladder. I need to find a ladder. Where do we keep the ladders? Where do we keep the light bulbs? Should I be changing the light bulb? Do I need to find somebody else to ask them about the light bulb, right? I don't know. This is a new combination. All of those individual steps, getting a ladder, asking somebody, open it. I gotta open up the light fixture. I don't know how that opens up. Does the front come off? Does the back come off? Right? Which direction? It's a rectangular box. Which way do you enter to get at the light bulb itself? These are all little bits that I don't know, but they will have answers. When you add all the little bits up, now that's the problem. It's a new combination of a bunch of little inconveniences of changing that light bulb. Math has to address that, right? Our definition of math needs to be able to be used to solve problems, right? And related to that, just because it often comes up, is the nature of intelligence. And this is another big one. People like to throw this word around, especially describing people. You're intelligent, you're not intelligent, you're smart, you're dumb, right? You're in the advanced class, you're not. You're in the remedial class because you're stupid, right? What does any of that actually mean? Okay? Like, you guys are a class ahead, a year ahead. Is that because you're smarter than the sophomores in geometry? Are you more intelligent? Or did you just already know the other stuff? You just got a head start. You didn't solve any problems they won't. You just did them faster. You did them sooner. And a long view, I'm looking like at throughout the years of your life, the years of your school career, you were able to solve those problems sooner, right? You finished the algebra problems. You got to go on to geometry for high school, right? Whereas the other ones, they'll still solve the problems. They'll get an answer. They just didn't solve them as quickly. Right? To me, that's the difference. Say someone is intelligent, that they're just solving a problem faster. Okay? And so it's not a solid state. Intelligence is not locked in. It's a continuum. It's a journey. And it's just how far along are you on the journey? Some people move at different paces. Right? Just like people run at different speeds. Your brains run at different speeds. That's all that is. That's just a matter of, okay, how fast is your brain processing this? It's like computers have processing speed, and you upgrade them so often. Your brain can upgrade processing speed too. That's what practice does. So you can get more intelligent. It is possible to move forward. And we'll talk more about problem solving on Wednesday, specifically how to go about problem solving. But all of this does relate to mathematics, right? What is mathematics to intelligence? What does it mean to be smart or good at math? Just means you solve them quicker. Okay. How about science? Art, mathematics, right? School subjects, totally different classes, unrelated. Are they? What is math? Is math science? Is it an art? What is science and art? Before we can address what math is, we got to know what these base things are. How do they compare? What's the difference? Science, often described as the pursuit of knowledge. That's where the word comes from the Greek roots, knowledge, or the pursuit thereof. Okay? It's finding new stuff. Okay? Art has almost nothing to do with knowledge itself. It's expression, right? It's creativity. It's making creative, new, thought-provoking combinations of ideas, right? It's taking that thing I called thought, bringing it forward into the real world that you can present and share with other people. Right? Remember, art doesn't have to be visual. It can also be auditory. Those are my initial thoughts there in the gray. And then I came across these definitions I added here in blue, and I really liked these, how they pair up and contrast with each other. Science itself is objective. It is the acquiring of knowledge, whereas art is subjective. Okay? It's different for different folks. And it's expressing that knowledge. It's not acquiring new knowledge, but it's taking what you already know and sharing it with others in a different way, or maybe the same way, but it's subjective. It's your version of that way versus somebody else's version of that way. Does math have some of these? So the reading, The Mathematician's Lament, that you read over break. His lament was that we often seem to teach math in school as more of a science when it could be thought as more of an art. In fact, I would say it's not even taught as a science. We don't pursue new knowledge in math class. It's just memorizing facts as it's often presented. Here's this function, here's how it works. Memorize that, right? Here's this list of vocabulary terms you have to know. Here's this list of calculations you have to be able to do. It's a process. It's memorizing a process. Rarely do we get to explore in math. Root around, find out, okay, what does this do? What if? That's the key question, right? What if I take this and I add it to that? Right? How did you get polynomials? We took monomials and we started adding them together. Well, I could add numbers together. Can I add letters? Can I add things with exponents? That's how we got polynomials, right? People started trying this. They put things together. And the problem now is that a lot of the good stuff has already been tried, right? In a way, math class is almost like a history class. You got to catch up to all of the stuff that people have already pursued and figured out already, and now we're sharing with you. And so it's reading into their art. How are they to come to express it? How are you going to express it yourself when you write it out yourself, when you make your own graph? Is that the art? And you get to express yourself. And that was the mathematician's lament, that maybe we should treat it more like an art. Allow students to get creative, play around with the numbers, right? I love the contrast he makes to an art class in high school. You would never find art class in high school, where they never get to actually paint. No. First you must memorize the colors. Then you must memorize the combinations of the colors. You must memorize the types of brushes, right? The types of brush strokes, right? And then only at the very end, senior year, advanced painting 4, do you get to put paint to canvas. But that's only a paint by numbers, and you fill all those in, right? It's the PhDs there at university. They get to express themselves and get a blank canvas to paint whatever they want, right? That's crazy talk. How come you're not able to invent new math in high school? You don't get to play with the numbers. It's always rote memorization. Well, I would say that math is kind of all of those. Math is science. There is this knowledge that you can uncover and find through exploration, through testing, through experimentation. Okay, what if I add this to that, and what happens? And there's an art to it. You can express yourself mathematically. It expresses ideas. It expresses knowledge. When I write out an equation, this says something. You can interpret this. It has meaning. So in fact, it's more than just any art. It's a language, right? It communicates ideas. We have a shared language within mathematics where we all agree what this means. We can communicate those ideas to each other, and we can express different variations, based on changing the variables. It's interesting to think about. And I often wonder if we'd be better off treating, maybe not as an art, but the language arts. Language is often grouped in with arts, right? What if we taught mathematics like language? Like, a foreign language class, right? There's vocabulary. Okay? You've got to know all these terms. There's grammar. There's a structure to it. You can't just arrange these however you like. Okay, this has to come before that. And we have an order to it. There's rules to follow when you put these together. That's grammar, structural rules. Maybe we should treat it like a language. Teach it like a language. Have a spelling test at the end of each week, right? A math spelling test. will be the equivalent of a math spelling test. It's interesting. So it has aspects of all of these, and it gets applied to a lot of scenarios, but math itself still has that purest form below the surface, right? And that's why I wanted to boil it down to a single definition. And I don't remember if I know I did with the geometry. I don't remember if I did with you. Did we do the one-word math classes? I can bring those up to remind you. One. This thing, right? This has summarized the different math disciplines into a single word. Calculus is the mathematics of change. Algebra is the mathematics of relationships. Geometry is the mathematics of space, so on. That's great. How about all of math? Can we say math is the study of one word? You can do it with biology. Biology is the study of life. Easy. Nobody doubts that. Nobody says, yeah, but what about? They're like, yeah, that's pretty good. Maybe on the very edge there's some fringes here and there. But that is a pretty good job. What's one word that you can say, that pretty much covers 98% of it. You got math. Bingo, right on. I tried finding this. Tried thinking about it myself. Took me ages. Found an answer that I actually like. I'm going to share it with you. Here it is. Mathematics is the study of structure. Think about that for a moment. Remember, algebra was the mathematics of relationships. And you could expand that. You could almost describe any of the maths as relationships between ideas, right? But math does something more than that, because lots of things actually are relationships, okay? Language is relationships between sounds, right? It has grammar and vocabulary, letters. A relationship between a written symbol and a vocal sound, that's a relationship. Wow, lots of things are relationships. History is full of relationships. So that wasn't good enough. That could be too generalized. But what does math do to those relationships? It imposes rules, right? Algebra is the mathematics of relationships. The mathematics part says, I'm studying the rules of relationships, the structure of relationships. Geometry is the study of the mathematics of space. It's not the study of space. Space is in dimensional place that things take up, not outer space. Okay? Geometry is the study of the structure of space and shapes. Now you see where I'm going with this, right? It's what are the rules? What are the fundamental ideas that I can count on that don't change, right? That has a logic behind them. Logic itself is structure, rules to find truth, false. That is a mathematics. That is the topic that we are studying. But it's not quite complete. I couldn't leave it at that, just the study of structure, because that's not how we use it. We don't use the term math to refer to just the study of structure itself. We need a definition B, right? Don't you hate it when you open up the dictionary or look it up online, dictionary.com, right? Do you guys even have paper dictionaries at home? Anyways, you look up something and you feel like there's like 5 different definitions. They all sound completely different. You're like, I don't know which one. Right? We have multiple uses of math. The second, mathematics can refer to the language used to describe structures. Okay? So it's got 2 different roles. It's the study of it itself as well as talking about those structures. That's that language component. That's that artistic expression to convey those ideas. Okay? You need those different ideas. and we apply that structure. This is why mathematics is so applicable, right? It's really useful because we can study the mathematics of anything, right? Biology can have some mathematics. It's not quite as obvious, but it's there, right? Chemistry, physics, all the sciences can have math applied to them, right? The math just either studies or at least describes the structures, right? The laws of physics, right? Universal law of gravitation, right? That's describing relationships between, bodies with mass, and we use the math, that equation, to describe the structure of that relationship. Okay? If you wanted an even more direct, instead of applying math to another discipline, we could apply math to the real world. What if you brought the study of structure into physical space? Well, then you get architecture, right? You get building houses. There's differences in houses, right? Different buildings are shaped that way for a reason, right? We have this building for school. Well, it used to be a Kmart, but they built it that way for a reason, right? We designed the classroom for a reason. In fact, we have classroom rules for a reason, because the classroom rules create a structure designed for learning. Structures can be constructed to help a purpose, right? They serve a purpose. Why is it that northern houses all look like this, right? Around here, all our buildings, for the most part, have sloped roofs, whereas a lot of houses and buildings down south don't need to, right? Think of the old Pueblo buildings in, New Mexico, right? They've got flat roofs. Why would it be a bad idea to build your house with a flat roof in Illinois? You can go ahead and answer that.
We could say that, it snows a lot here.
It snows a lot here, yeah. And the snow would be the worst part, but even less so the rain, right? We get more rain than New Mexico, right? States like what, half desert, okay? Even the rain would, it'd puddle up, right? You don't want that sitting on your roof, right? You want it to fall right off. Same with the snow, right? If it builds up and it just stacks up, it's gonna collapse. Snow gets heavy, right? Ice gets heavy. You need it to be able to fall off of there, right? That's why we have those. Those structures are designed with a purpose, okay? So architecture, direct real-world implementation of mathematics itself. I think you can see purpose behind it. So math is studying these types of structures of ideas so that they could be applied to various settings, or not. Or maybe you just want to study them for the heck of it. Let's see what happens. Let's just have fun with it. How many times in chemistry class have you heard not to do something, right? Chemistry is very volatile of the high school sciences because you deal with possibly caustic chemicals. They can be very dangerous. And so the teacher tells you, okay, don't mix these two together, right? Or don't touch this, right? It's acid, it's gonna burn you and melt your skin off, okay? You're like, yeah, but what if I did? What does happen when you mix them? Why did you just tell me, don't mix these two things together? What happens if I do, right? You're curious. You're asking that what if question. Mathematics can have that what if question. It's just, in the realm of pure mathematics, in the classroom setting, we don't quite have the bright, colorful, flashy after effects. It's not as visual of a result. But it's still there. You can still get curious with it. Ask, oh, what if we did this? Root around with it, play with it. And then figure out a way to report your results. What happened? Let us know. Maybe somebody else was curious too. That's mathematics. Okay. Any questions from you? All right, then we've still got 10 minutes left. Go ahead and use that to type up your answers to those discussion questions. What is math? Is it art? Is it science? And add as much detail as possible. Add things you found from Mathematician's Lament, add your own ideas, add things that I've said, throw it all in there, okay? Especially your own ideas. I want to hear what you think. In fact, I never got the link up. Whoops. Here would be a good one. If math is both science and art, specifically a language art, which is it more of? Is it 50-50? Is it a perfect balance? Is it more science or is it more art? That'd be a good one. Include that somewhere in your answer. I'm almost tempted to like make a poll. Like, how many of you think it's more of this, which one or the other? Let's see what you think. Which one is the majority? Or is it equal? Perfectly balanced as all things should be? Let me know what you think. All right? And for you guys, I'm just looking ahead at the schedule. Yeah, so that's it for today. Just get those questions answered, turn that in on Google Classroom. That is your only task for today. Tomorrow we'll talk about the different study levels and how that will affect the assignments going forward. And there's a reading to go along with that. And then Wednesday night you'll read the first section for Chapter 8, and the actual math subjects will begin.